Welcome back, everyone. Ready to dive into another fascinating corner of prehistory?
Absolutely. Always excited to explore the ancient world.
Today, we're strapping on our helmets and heading back to the age of dinosaurs, specifically to meet the ankylosaurs.
Ah, yes. The armored tanks of the dinosaur world.
Exactly. Those incredible creatures covered in bony plates and spikes, some even sporting a powerful tail club. I mean, talk about impressive defenses.
You're not kidding. Ankylosaurs were marvels of evolution, developing some of the most incredible armor the animal kingdom has ever seen.
So where do these walking fortresses fit in the grand scheme of dinosaur evolution?
Well, they belong to a larger group called Thyreophora, which means shield bearers.
Shield bearers makes sense. So are we talking about a whole family of armored dinosaurs?
You got it. This group includes the famous stegosaurs, those with the plates running down their backs.
Right, the stegosaurs. I remember learning about those in grade school.
And of course, the ankylosaurs are stars of the show today.
So two branches of the same armored family tree. Pretty cool.
Hmm.
But for this deep dive, we're focusing specifically on ankylosaurs, right?
That's right. We'll be uncovering how these armored giants evolved, the unique characteristics that set them apart, and the adaptations that allowed them to thrive for millions of years.
I'm ready to get armored up and dig in. So where do we even begin with a group as vast and diverse as the ankylosaurs?
Well, like any good detective story, we should start at the beginning, with their origins.
Sounds like a plan. Take us back to the beginning.
Now, the early ankylosaur fossil record, it's still a bit of a mystery, but we do have some intriguing clues.
Oh, I love a good paleontological mystery.
One of the earliest possible ankylosaurs is Chirotherium. It was discovered in the UK.
The UK. Wow, that's unexpected. I always picture dinosaurs roaming around North America.
They were all over the place. Anyway, Chirotherium dates back to the Middle Jurassic period, around 165 million years ago.
That's right around when stegosaurs were stomping around, isn't it?
Hmm,
So they were sharing the same environments.
seems so. And around the same time, we have Ankylosaurus unearthed in China, so pretty far apart.
Wow. So even in those early days, ankylosaurs had a global presence. That's amazing.
It really is. And it speaks to their early success spreading across continents, even at that stage of their evolution.
So we have these early ankylosaurs
Hmm.
already making their mark on the world. What happened next? How did they evolve from there?
Well, at the end of the Jurassic period, something big happened that really shook things up for the ankylosaurs.
Uh-oh. Sounds ominous. What happened?
The stegosaurs went extinct.
So one door closes, another one opens. Classic evolutionary tale.
Exactly. With the stegosaurs out of the picture, a major ecological niche opened up.
And I bet the ankylosaurs were ready to step right in.
You bet. They diversified to fill that niche. And this is where we see the rise of the Nodosaurids.
Nodosaurids. That name rings a bell. Weren't those the ones with the heavy armor and spikes but no tail clubs?
You got it. They were heavily armored, but lacked those iconic tail clubs we often associate with ankylosaurs.
Okay, I'm picturing a heavily armored dinosaur, bristling with spikes. Sounds intimidating.
Oh, they were. And their defenses were quite effective.
So even without the club, they were well equipped for survival.
Absolutely. Early nodosaurids, like Polacanthus, had spines that actually pointed upwards.
Ouch. Not a good place to land if you're a predator. So those spikes were deterring predators from trying to, what, jump on their backs?
That's the idea. But, as you might imagine, predators probably learned to avoid their backs.
Makes sense. So what did the Nodosaurids do? Just give up?
Not at all. They adapted, of course. Later species, like Gastonia, they developed spines that pointed sideways.
Clever. So protection from attacks from the flanks. It's like an evolutionary arms race, constantly adapting to outmaneuver the enemy.
Exactly. And, it's a theme we see throughout Ankylosaur evolution. They were constantly refining their defenses in response to the threats they faced.
That's fascinating. So where were these Nodosaurids hanging out? Were they mostly in North America?
Primarily, yes. North America was a nodosaurid stronghold, but they did venture out to other continents.
Oh, really? Where else did they end up?
Well, in Europe, for example, a distinct group of nodosaurids called Polycanthidae evolved.
So even within the Nodosaurids, there was diversification and regional evolution.
Hmm.
It's incredible how life finds a way to fill all these different niches.
It really is. And it gets even more interesting when we look at specific examples.
Oh, I'm all ears. Give me some highlights.
Well, there's one Polycanthid that really stands out, Boreala pelta.
Boreala pelta. That's a mouthful. What's so special about it?
It's from Canada, and its fossil is remarkably well preserved.
Oh, wow. So we're talking pristine bones, maybe even some soft tissue.
It actually reveals incredible details like skin texture and even its color.
Wait, we know its color. How is that even possible after millions of years?
It's amazing, isn't it? It was reddish-brown.
Reddish-brown, so not green like I always pictured dinosaurs.
Nope, reddish-brown. And, there's a theory about that coloration.
I bet it has something to do with camouflage, right? Blending in with the environment.
Exactly. The reddish-brown coloration could have helped Boreolopelta blend in with its surroundings, making it harder for predators to spot.
That's so cool. So even though Nodosaurids lacked those tail clubs, they had their own unique set of defenses. Were they found anywhere else besides North America and Europe?
They even made it all the way to Australia. There's Minmi, a small basal ankylosaur that lived there about 104 million years ago.
Wow. So Nodosaurids were pretty widespread. But what about the other branch of the family tree? The Ankylosaurids, the ones with the tail clubs. When do they enter the picture?
Well, they likely appeared around the same time as the Nodosaurids, but their early fossil record is, unfortunately, a lot less complete.
So more gaps to fill in the story. That's always a challenge in paleontology, isn't it?
It definitely keeps things interesting. But we do have some intriguing clues about early Ankylosaurids, and some of them might surprise you.
Oh, I love surprises. Hit me with it.
Picture this. China, 124 million years ago. A tiny ankylosaur, only 34 centimeters long, is darting through the undergrowth.
A miniature ankylosaur. Ah, that's kind of adorable. Like a little armored puppy.
Right. This little guy is Leoningosaurus, and it happens to be the smallest ankylosaur ever discovered.
So we're talking pocket-sized ankylosaur. But I have a feeling there's more to this story. It's not just its size that's remarkable, is it?
You're right. Leoningosaurus was unique in another more surprising way. It was a meat eater.
A meat-eating ankylosaur. Hold on. I thought they were all herbivores. What's going on here?
Yeah, it was definitely an exception to the rule. In fact, Leoningosaurus is the only confirmed carnivorous ornithischian dinosaur.
Ornithischian. Refresh my memory. What does that mean again?
It's the group that includes all those plant-eating giants like Triceratops and Stegosaurus.
Right, right. So even within this group of mostly herbivorous dinosaurs, we had a little rebel who decided to go against the grain. Fascinating. What made Leoningosaurus a meat eater? Was it a holdover from some ancient ancestor, or did it evolve this diet on its own?
It's a question that still has paleontologists scratching their heads. It's possible that this was a special adaptation to a very specific ecological niche. You see, Leoningosaurus had fork-like teeth and a more streamlined body.
So those features suggest it might have been adapted for what? Catching fish?
That's the leading theory. A fish-eating ankylosaur. Who would have thought?
It just goes to show evolution is full of surprises. But I imagine this was a rare exception, and most ankylosaurids stuck to a plant-based diet.
Absolutely. The vast majority of ankylosaurids were herbivores, and their rise to dominance is closely tied to big changes that were happening in the plant world during the Cretaceous period.
Now, this is where it gets interesting for me. I've always been fascinated by how the evolution of plants and animals are so intertwined. So how did plants influence the ankylosaurids?
Well, remember those nodosaurids we talked about earlier? They had those serrated teeth, perfect for grinding up tough, fibrous plants, which were the dominant plants for a long time.
Right, the Nodosaurids were like plant processing machines. But something must have happened to change that balance, right?
You got it. About 117 million years ago, there was this significant extinction event called the Aptian extinction.
An extinction event. Not as big as the one that wiped out the dinosaurs, I'm guessing.
No, not that big. But it still had a major impact on life, especially plant life. We saw a decline in those tough, fibrous plants that Nodosaurids loved, and at the same time, ferns with their softer leaves started spreading.
And I'm guessing that shift in vegetation gave the Ankylosaurids an edge. Weren't their teeth better suited for softer plants?
You're catching on. Ankylosaurids had smaller, leaf-shaped teeth, perfect for munching on ferns and other softer plants. And that change in plant life, it really helped set the stage for their rise to prominence.
So plant evolution helped pave the way for the Ankylosaurids. It's amazing how everything is connected. But what about their most iconic feature, the tail club? When did that come into play?
Yes, the tail club. The hallmark of the Ankylosaurids. But it wasn't something that just appeared overnight, you know?
Right. These things take time. Evolution is a gradual process.
Exactly. The tail club developed gradually over millions of years. First, a stiffened tail.
So like a proto-club, a club in the making.
Exactly. And then eventually the development of that bony knob at the end of the tail.
And boom, you have a powerful weapon. I can just picture those early Ankylosaurs swinging their tails, trying to ward off predators. But once that bony club evolved, it must have been a game changer.
Oh, absolutely. The tail club was a formidable weapon. It could deliver bone-crushing blows, deterring even the largest predators.
So we have these Ankylosaurids with their armored bodies, powerful tail clubs, and a changing plant world that's working in their favor. Sounds like they're becoming unstoppable.
They were certainly well-equipped for survival. But their story doesn't end there. Ankylosaurids continued to evolve, continued to diversify, developing even more fascinating adaptations. And we'll dive into those in our next segment as we explore the Late Cretaceous period when Ankylosaurids truly dominated the landscape.
This is getting exciting. Can't wait to see what other surprises these armored marvels have in store for us. Welcome back to our deep dive into the amazing world of Ankylosaurs. Last time we left off with Ankylosaurids on the rise, their tail clubs evolving, and a changing plant world giving them a boost. And now we're entering the Late Cretaceous period when those Ankylosaurids really hit their stride.
That's right. The Late Cretaceous was a time of massive change and diversification for the Ankylosaurids. They spread to new territories, evolving all sorts of special adaptations, truly becoming those dominant armored herbivores of their time.
So prime time for the Ankylosaurs. What were some of the big things that happened to them during this period? What shaped their evolution?
Well, one of the most significant events was, get this, the connection of Asia and North America.
You mean like a land bridge?
Exactly, the Bering Land Bridge. It acted as a corridor for all kinds of animals, including dinosaurs, allowing them to move between continents.
So Ankylosaurs were on the move, spreading to new lands. Did this lead to, like, any interesting interactions or competition?
Absolutely. It was a real melting pot of species. And Asian Ankylosaurids, they migrated to North America. We see evidence of this in the fossil record.
Oh, that's cool. Do you have any examples?
Sure. Pinacosaurus, an Asian ankylosaurid, it migrated to North America and actually gave rise to a whole diverse group called Ankylosaurini. And these ankylosaurians, they were really successful in their new home.
So they didn't just migrate, they thrived in a totally new environment. Adaptable, weren't they? Did any other Asian ankylosaurs make the trip?
Yeah. Echinocephalus, for example, found in Utah. And its skeletal features are actually more similar to Asian ankylosaurs, which supports that whole migration theory.
Fascinating. So we have these Asian ankylosaurs heading over to North America, but what about the Nodosaurids that were already there? Any competition?
You bet. The arrival of those ankylosaurids must have put pressure on the Nodosaurids. I mean, they had been the dominant armored herbivores in North America for millions of years.
A clash of the titans. So who came out on top?
Well, if you look at the fossil record, it seems the ankylosaurids were ultimately more successful. They gradually outcompeted those Nodosaurids, becoming the top armored herbivores in North America by the Late Cretaceous.
I guess even though Nodosaurids were well defended, those tail clubs gave the Ankylosaurids an edge.
Seems that way. The tail club, a powerful weapon, no doubt. But Ankylosaurids also had some other adaptations that helped them dominate. Might surprise you.
Oh, I do love a good dinosaur surprise. What else do they have going on?
Well, how about armored eyelids?
Armored eyelids? Seriously. Their eyes were protected by bone, too.
You got it. Some species had bony plates right over their eyes.
Which species had those?
Well, we see that feature in a few, like Zool and Scalosaurus. Euoplocephalus, too.
Euoplocephalus. That's the one that's always getting confused with Ankylosaurs, right?
That's the one. People mix them up all the time. But there are some key differences. Ankylosaurus has a more triangular head shape, while Euoplocephalus, it's got a more rounded head and those distinctive shoulder spikes.
So we have to be careful not to get our Ankylosaurs mixed up. But back to those armored eyelids for a second. Why would they even need that? Were their eyes, like, super vulnerable?
Well, think about it. A predator tries to bite an Ankylosaur's face. Those bony eyelids would have provided extra protection for those eyes, a very sensitive area.
Like a built-in face shield for their eyes.
Huh.
Makes sense. Armored bodies, tail clubs, armored eyelids. Any other cool adaptations we should know about?
Oh, their armor, it was constantly evolving, getting more and more elaborate. Remember Edmontonia, that nodosaurid we talked about earlier?
The one with the incredibly thick bony plates.
That's the one. Edmontonia's plates were serious business, 5 to 8 millimeters thick on average.
Wow. Talk about heavy duty.
And some of those plates, they could even reach up to 1.5 centimeters thick.
A true walking tank. But here's a question that's been bugging me. If they were so well protected, how did they eventually go extinct?
That's a question that's puzzled paleontologists for a long time. I mean, ankylosaurs survived for millions of years, weathering all sorts of challenges, changes in the environment.
So what happened? What finally did them in?
Well, as we get to the end of the Cretaceous, we encounter that cataclysmic event that changed everything on Earth. The Chicxulub asteroid impact.
Ah, yes. The infamous dinosaur killer. Hard to imagine anything surviving that.
A global catastrophe. About 66 million years ago, a massive asteroid slams into Earth, triggering widespread devastation and marking the end of the Mesozoic era.
So not even those impressive ankylosaur defenses could withstand the asteroid impact.
Sadly, no. Despite all their adaptations, ankylosaurs, along with so many other dinosaur groups, they couldn't survive the global environmental changes that followed the impact.
What kind of changes are we talking about?
Well, think massive wildfires, tsunamis, earthquakes, dust and debris filling the atmosphere.
Blocking out the sun, plunging the planet into darkness.
Exactly. And the temperatures, they plummeted, disrupting plant life, collapsing food chains.
So it wasn't just the immediate impact that was deadly, but the long-term effects on the environment.
Right. Even if some ankylosaurs had managed to survive that initial impact, they would face a world completely transformed, a world that was no longer hospitable to them. Their food sources would have been gone. The climate, too harsh.
A sobering reminder that even the most successful creatures can be vulnerable to forces beyond their control. It makes you wonder, though, what if the asteroid hadn't hit? Would ankylosaurs still be around today? What would they have evolved into?
Now, that's a fascinating thought experiment. We can't know for sure, of course. But given how adaptable and resilient they were, who knows? They might have continued evolving, developing even more specialized adaptations in response to new environments.
I love that image. Ankylosaurs roaming the Earth today. What a sight. But even though they're gone, their fossils give us such incredible insights into dinosaur evolution.
Absolutely. They teach us about adaptation, survival, and the amazing diversity of life that once existed on our planet.
And it makes you appreciate the life we have today and the importance of protecting it. We've learned so much about ankylosaurs, but I'm sure there are still mysteries out there waiting to be uncovered.
Definitely. Every new fossil discovery can change what we know about these incredible creatures. The future of ankylosaur research is wide open.
That's what's so exciting about paleontology. It's a constantly evolving field. New discoveries, new perspectives. I'm already looking forward to the next chapter in ankylosaur research.
Me too. These armored giants, they'll keep captivating our imaginations for years to come.
Well said. Okay, so as we wrap up our deep dive into the world of ankylosaurs, what's the biggest takeaway you hope our listeners will remember?
I think it's the importance of appreciating the incredible diversity and resilience of life, past and present. Ankylosaurs, they remind us that evolution is a constant process of adaptation, and that even the most well-defended creatures are part of a bigger web of life.
A beautiful thought. We've explored their armored bodies, their powerful tail clubs, but their story ultimately is about the interconnectedness of life, that delicate balance of ecosystems.
Exactly. And their story continues to unfold as we discover more about our planet's ancient past.
Well, on that note, I think it's time to bid farewell to the ankylosaurs, at least for now. To all our listeners out there, thanks for joining us on this deep dive into the world of these armored giants. Keep exploring, keep questioning, and keep that sense of wonder alive.
Until next time.
Wow, what a journey it's been. From those early ankylosaurs to the rise of the tail club to those incredible adaptations like armored eyelids. Ankylosaurs really were remarkable creatures.
Absolutely. They survived for millions of years, adapted to all sorts of changes, truly a success story in the history of life.
And yet, even with all their impressive defenses, they couldn't escape that asteroid impact. It kind of puts things in perspective, doesn't it?
It really does. The Chicxulub impact, as it's known, was a turning point, not just for the dinosaurs, but for so many other forms of life on Earth.
I mean, those immediate effects of the impact, the tsunamis, the wildfires, the earthquakes, must have been absolutely devastating. Hard to imagine anything surviving that.
It was a global catastrophe, no doubt about it. But, it was actually the long-term environmental changes that really spelled the end for the dinosaurs, including our ankylosaurs.
Right. You talked about how that impact plunged the planet into darkness, messed up the plants, disrupted those food chains. Big herbivores like ankylosaurs, they wouldn't have stood a chance.
Exactly. Their world was completely changed, and not for the better. The lush vegetation they depended on, gone. The climate, way too harsh.
A sad ending for such a successful lineage. But even though they're gone, those ankylosaur fossils, they give us such a glimpse into that lost world.
Absolutely. They're like clues, helping us piece together what life was like millions of years ago. They tell us so much about adaptation, about survival, about the incredible web of life that existed on our planet.
And it makes you realize how precious life is, how important it is to protect the amazing biodiversity we have today. We've learned so much about ankylosaurs, but I have a feeling there are still so many mysteries out there waiting to be discovered.
Oh, definitely. Every new fossil, it has the potential to rewrite what we know. There's always something new to learn, something new to be surprised about.
That's the beauty of paleontology, isn't it? It's a constantly evolving field, always something new on the horizon. I can't wait to see what the future holds for ankylosaur research.
Me too. Ankylosaurs, they've captured our imaginations, and they'll continue to do so for generations to come.
Well said. So, as we wrap up our ankylosaur adventure, what's the one big thing you hope our listeners take away from all this?
I'd say it's the importance of appreciating the diversity of life, past and present, how resilient life can be. Ankylosaurs, they teach us that evolution is a constant process, a dance between adapting and surviving, and that even the most well-defended creatures are part of something much bigger.
That's a beautiful way to put it. We've talked about their armor, their tail clubs, their amazing adaptations, but their story really is a story about the interconnectedness of life, of how ecosystems work.
Exactly. And it's a story that keeps going as we learn more about our planet's past, about those incredible creatures that came before us.
Well, on that note, it's time to say goodbye to the ankylosaurs, at least for now. To our listeners, thank you so much for joining us on this journey. Keep that curiosity alive, keep exploring, keep asking questions about the world around you.
And until next time, happy fossil hunting.